Your FastMCP server just updated its tools, but your client is still using stale data. How do you keep everything in sync automatically? We'll implement a message handler that listens for server notifications, showing exactly how to detect tool changes and resource updates in real time. The pattern uses FastMCP's built-in notification system to trigger refreshes without polling or manual checks. From FastMCP import client. Async def message handler, message. Handle all MCP messages from the server. If hassetter, message, root. Method equals message root method. Printf received, method. Hash handles specific notifications. If method equals, notifications tools list changed. Print, tools have changed, might want to refresh tool cache. Elif method equals, notifications resources list changed. Print, resources have changed. Client equals client. My MCP server, hi. Message handler equals message handler. This demonstrates the observer pattern for handling asynchronous server notifications. The code establishes a single message handler that acts as a centralized listener for various event types, enabling reactive programming without tight coupling to the event sources. What makes this distinctive is its ability to process different notification types through a unified interface, while still allowing specific handling logic for each case. The pattern works by delegating message routing to the framework while keeping your handler focused on business logic. FastMCP automatically dispatches incoming messages to your handler, where you can filter by message type and respond appropriately. This separation of concerns means your application logic remains clean, only dealing with the events it cares about, while the framework manages the underlying transport and message parsing. This approach solves the problem of maintaining state synchronization between client and server in distributed systems. It's particularly valuable when you need to react to server-side changes like tool updates or resource modifications without constant polling. The trade-off is that your handler must be prepared to process messages asynchronously, which requires careful design around shared state and concurrency. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the core component for connecting to MCP servers. This handles all low-level communication, message serialization, and connection management with the server. Async def message handler, message. This defines an async message handler for FastMCP's event-driven architecture. It processes incoming server messages asynchronously, enabling non-blocking operations while handling real-time notifications like tool or resource changes. The async pattern is mandatory here because FastMCP's client-server communication is fully asynchronous. Handle all MCP messages from the server. This docstring declares the function's purpose as the central message handler for all incoming MCP server messages. It establishes the contract that this function will process every message type, enabling centralized control over server-client communication. If hassetter, message, root. This is a defensive check using Python's hassetter. It verifies the message contains a root attribute before accessing it, preventing attribute error if the message structure is invalid. This pattern ensures safe attribute access when handling potentially malformed MCP messages. Method equals message root method. This extracts the message type from the MCP protocol's root object. The method field identifies the specific notification or command being handled, enabling targeted response logic. Printf received, method. Debugging aid. logs the received MCP method name to verify message routing and identify which notification type arrived. Critical for diagnosing why specific handlers aren't triggering during development.
Hash handles specific notifications. If method equals, notifications tools list changed.
This checks for tool list updates from the server. FastMCP broadcasts this notification when tools are added, removed, or modified, letting clients refresh their local cache. The pattern mirrors REST's event-driven updates, but over MCP's async protocol.
Print, tools have changed, might want to refresh tool cache.
This log message signals tool cache invalidation. When the server notifies clients about tool changes, this indicates your local cache is stale and needs refreshing to maintain consistency with the server's current toolset.
A if method equals, notifications resources list changed.
This handles resource change notifications from the server, specifically when the available resources list updates. The pattern mirrors the tool's notification handler above, maintaining consistency in how different change events are processed. FastMCP uses this notification system to keep clients synchronized with server-side state changes.
Print, resources have changed.
This placeholder logs resource change notifications from the MCP server. It's a stub implementation showing where you'd add refresh logic for resource caches, ensuring your local state stays synchronized with server updates. The pattern mirrors the tool's notification handler above, maintaining consistency in event handling.
Client equals client.
Instantiates the FastMCP client, establishing the connection to the MCP server. This is the entry point for all server communication, handling message routing and protocol management.
My MCP server, hi.
This specifies the MCP server's entry point file. FastMCP uses this to locate and launch your server implementation, following the standard Python module resolution pattern. Without it, the client wouldn't know which server code to execute.
Message handler equals message handler.
This registers the message handler function as the callback for all incoming MCP server messages. The pattern establishes event-driven communication, where the server pushes notifications instead of requiring constant polling. This closing parenthesis finalizes the client instantiation. It completes the configuration with the specified server name and message handler, establishing the connection to the FastMCP server. Without this, the client would remain uninitialized and unable to process messages. Message handling pattern. The function-based message handler in FastMCP 2 provides a unified entry point for all server notifications, from tool changes to resource updates, using simple method inspection. The root method check is mandatory. Without it, you'll silently miss all notification routing. This pattern scales effortlessly from simple logging to complex state synchronization.
The handler that listens to everything hears only what it names.